Okay, so first I want to talk about what an angle of um, depression and elevation is. Okay, you need to know where they're located and that. Okay, so this top one here is an angle of elevation. So in this particular case, you are below what you are looking at above you. Okay. So here you're standing below something, you're looking up. The angle you have to raise your head to see the top of the building, the top of the tree, a balloon in the sky, whatever, you're looking up to that thing. Now, the opposite is an angle of depression. In this particular case, an angle of depression is if you were looking straight, you're standing up on a mountain. You look down to a little of something you see on the ground at the bottom of the mountain. Okay, it is not in the triangle. So again, you are looking down on something below you. So in this particular case, you're standing up on the mountain, you drop your head a certain percentage or a certain angle measure, and you look at something on the ground. Now, because of a technique from geometry that says if parallel lines are cut by a transversal, that alternate interior angles are congruent. This angle here can also be marked with theta. So let's say that was a little bug on the ground. If he lifted his head to see you standing up on the mountain, so if our little bug looked at you, he would lift his head up 10 degrees. If you were standing up on the mountain and looked down at the bug, you would have to drop your head 10 degrees. They would match. Okay, with respect to the ground, with respect to the horizon, whatever you want to say about it. But you have to remember that the angle of depression isn't necessarily in the triangle that you're going to draw. Okay, it's kind of outside the triangle, hitting your hypotenuse. So that's really important. Okay, so now that we've kind of talked about where they're located, I want to show you some examples. So let's take a look at our first example. It says that an angle of elevation to the top of a building in New York is found to be 9 degrees from the ground. So let's put 9 degrees right there. So an elevation is from the ground looking upward. At a distance of 1 mile from the base. So we're going to make that 1 mile. Using this information, find the height of the building. So we're going to put a little X right here. Now, most of the time, you don't measure a building in miles. So when that's the case, let's make that 5,280 feet. So let's think about what we know. This is the opposite. This is our adjacent. The trig function that's going to help us solve this problem needs to have opposite and adjacent in it. That's our tangent. So let's write down our formula. The tangent of theta is opposite over adjacent. So I know that the tangent of 9 degrees is opposite over adjacent. So let's go ahead and multiply through by 5,280. So I know that the tangent of 9 degrees times our denominator, 5,280, will equal x. And let's round it to the nearest foot. You got to make sure that your calculator is in degree mode. So you would have the tangent of 9 degrees times 5,280, and that would be to the nearest foot, 836 feet. So the building is 836 feet tall. So they're not super difficult per se. What I found is that just can I set it up right and then find the problem, the triangle that belongs with it. Everyone okay with example 1? So there is your first example. Now let's go ahead and do another one. Now this one is an example of an angle of depression. We're looking down upon something. It says, from the top of a fire tower, a forest ranger sees his partner on the ground at an angle of depression of 40 degrees. That's why this angle here has been marked 40 degrees. How far is the partner from the base of the tower? So this has been marked as our x. So what we want to know is if the tower is 45 feet, so that's why this is marked with 45 feet, how far away is the partner? Okay. So if we look at that triangle, we have 45 feet, we have x. We don't have 40 in our triangle, so we've got to get it there. Now, we can get it there in 2 different ways. You can put 40 degrees down here. Since a triangle's the 2 smaller angles are always going to be complementary, they're always going to add up to 90. You could also make that 50. It doesn't matter which way you approach it. So if you want to make that top angle 50 and use that, it will work, because yesterday we talked about how the cosine of one angle will be the sine of its other angle. The tangent of one will be the reciprocal tangent of the other. So it doesn't matter. So you can be a person that uses 50, you can be a person that uses 40. It doesn't matter to me. Now, if we use the 40, this is the adjacent, this is the opposite. I know that the tangent of 40 degrees is opposite over adjacent. So the tangent of 40 degrees times x, because we always cross multiply with our denominator, is equal to 45. So x is going to be 45 divided by the tangent of 40. So 45 divided by the tangent of 40 would be, let's go, it says to the 10th of a foot, so follow those instructions. If they don't give it, it's a good idea to go to the nearest 10th for a length, side length, and nearest degree for an angle measure. And so that would be feet. Now, how can we kind of get a sense that we are correct? The larger angle 50 should be across from something larger. So 53 is a little more than 45. It makes sense that 50 degrees should be across from the medium angle, 53.6, and 40 should be across from the smaller angle, 45. So it kind of makes sense that it worked out in that particular way. So that's our answer for number 2. Okay? Okay, any questions about those 2 problems? If you're getting a sense of how these work, you're getting it. That's what most of this project is about. Let's look at example 3. Now, example 3 is the hardest type. The hardest type are when we have these nested situations. Many times it is a hiker that started at one place, measured their information, walked forward and measured again, or the opposite could be true. They stood there, they walked out a little bit and measured. Okay. So it says the hiker is 100 feet from the base of the mountain. They calculate the angle of elevation to the top of the mountain is 68 degrees. He walks in 40 feet closer. So what we know is that this is 40 feet. This would have to be 60 feet because the total is 100 feet. The first time he looked at the 100 feet mark, the angle of elevation was 68 degrees. When he walked in again, now the angle of elevation is 77 degrees. Now this is an example where we want to know the height of the mountain, so we're going to put a little X right there. But we want to pull the two triangles apart, okay? We're going to have to pull the two triangles apart. I'm going to add myself a page. You might want to do so as well because of the fact we're going to have to do some things here. Okay. So the first thing I'm going to do, anytime you have this nested situation, is you want to draw two separated triangles, okay? So the smaller one is x 77 degrees and 60. The larger one is x 68 degrees and 100. Oh, this one is the easiest nested one I've ever seen because of the fact they didn't leave anything ambiguous. We could use either one. And so hopefully they've made it so that both give us the same height of the mountain or the mountain shifted in the few seconds. So if you use this information, this is the adjacent, this is the opposite. If you use this information, this is the adjacent and this is the opposite. And what's great, they have made it so that either triangle has only one unknown. So you can just jump right in. Hopefully they have done it right. This is the tangent of 77 is opposite over adjacent. This is the tangent of 68 is opposite. I said opposite over adjacent, but I didn't do that, did I? Is opposite over adjacent. Tangent of 68 is opposite over adjacent. We'll get what. So that is, did they say to round to a nearest? They didn't say that. It rounds very, very close to 260. So 260 feet. Well, that is the, just a second. We're going to do a little math here. Wait a second, let's try that. Okay, let's make this 68. It's close, it's close. Let's make it, to be a little more accurate, 68.7 degrees. Okay. It doesn't change much, but it does make the match a little nicer. Okay. So, and the way to check your work here, that would be the tangent of 68.7 degrees times 100. And it's still, let's make it 69 degrees. Sorry. I'm just trying to get to work out slightly more accurately. Sorry, I got those problems from the internet. That's what you get from not always check how accurate your information is on the internet. Let's try now. Let's see. Yeah, there we go. That'll work. Okay. It's about, I think it would need to be like 68.8 or 9 to make it most accurate. But anyway, so that one is a nested one, but not quite as complicated as that most are. Yeah.
Is there a way to figure out like tangent, cosine, like sine without a calculator?
Yeah, we'll get there. There are some ways that we can use, that we can find the tangent, sine, and cosine without a calculator of certain things. So we're kind of limited. Multiples of 30, 60, 90 are going to be ones we're going to focus on. There are ways to even break it down to multiples of 15, but we're a little bit limited of what we can do without a calculator. By the end of this semester, you will know lots of ways to find some trig things without a calculator. So there are going to be some memorization stuff we'll practice, so that we can, like my students in calculus, if I tell them what is the sine of 30 degrees, they just know it. So there'll be stuff we're going to just learn. There's some patterns that are really cool that I'll teach you. But yeah, good question. Okay, so now let's talk about your project. In the project here, there are 20 problems to complete. That is one thing. It's like a homework that's 20 points, 1 point per problem. There are 20 problems there. You're going to do them all. Okay. The next thing is that there's a little bit actually more than 20. So if you do all of them, you could get a few bonus points. 1 point for each one you do extra. And they're going to be graded for correctness. You'll also notice the answers are already down at the bottom, so you can check them as you go. Okay. The next thing we're going to do is you're going to do a poster. When I first made this project, it was during COVID, so we did a digital version. When we did it before, we did a paper version. I am going to give you paper. I want a paper version. Anyway, you're going to pick a problem from, I'm going to walk around and you're going to choose a problem. And from that problem, that's the one that you have to depict, the only one you depict on your poster. You're going to follow the rubric you see here. The rubric it shows 30 points and how to get those 30 points. So you want to focus on this column. And if you focus on this column, you're going to get 30 points. Now at random, if you get one of the most difficult problems, you actually, if you do your poster and show everything perfectly, you can get yourself 5 bonus, but that's just luck of the draw. Okay. Here is an example what I would want to see on a poster. Okay, so let's talk about what. There's a little title there. You make up the title. I don't care what it is. I have shown all the math step by step. I have drawn a depiction. If like me, if you're like me and you are not the greatest artist in the world, I found some pictures out there on the internet and just like clip arts and threw those in. I expect to see the answer of the problem, the picture, step by step, and please write the problem out. So this is what I want. Let's say that you are like one of my calculus students. They did this project. They could read this over and they could check it and understand everything because they have the problem, they have the steps, and they have the just information in general. So that's what your project should entail. You're going to have the next 3 days to today, if you count today, tomorrow, and Friday to work on this. It is due by the end of class on Friday. So you have all those. I'm going to get you, you're going to pick a problem here in a minute. I'll give you the poster stuff, but my suggestion, start the 20 problems. Do yours first because you want to check its accuracy before you jump in and do any other problems. So once you've picked your problems, do that first, then do the 20 problems, then make your physical poster. Are there any questions about the project and what is expected? Okay.